All right, let's dive into the incredible geological story behind one of nature's most beautiful and, frankly, unusual treasures, blue salt. I mean, just look at it. It's a mineral that seems almost too perfect to be real, doesn't it? So, we all know salt, right? It's white, it's crystalline, it's probably on your kitchen table right now. But blue? That's a whole other story. The big mystery we're exploring here is how a substance as common as sodium chloride can naturally get such a rare and luminous color. To find the answer, we have to go way, way back in time. I'm talking millions of years into the past. Our story doesn't start in a mine, but at the bottom of a long-vanished ancient sea, in the region that we now know as Eastern Turkey. So this whole process began on a timescale that is just immense. Over countless eons, huge inland seas in this area went through these repeated cycles of evaporation because the climate was always changing. And every single time a sea dried up, it left behind these thick, thick layers of salt, or halite. Eventually, these massive salt beds got buried and packed down, deep, deep under younger layers of sediment. But being buried was really only the first chapter of the story. Next, the raw power of our planet started to reshape that simple salt into something truly extraordinary. The Tuzluca region is basically a geological battleground. It's the meeting point of three colossal tectonic plates, the Anatolian, the Arabian, and the Eurasian. Can you just imagine the unbelievable pressure from this slow-motion collision? It fractured and squeezed those ancient salt deposits deep underground. And this is where the process shows how geological chaos can actually create perfect order. That intense fracturing created these small, protected pockets within the salt beds. And in these little sealed-off fluids, saline fluids allowed new halite crystals to grow very, very slowly and without any disturbance. The result? Exceptionally clear and perfectly formed cubes. Okay, so we have these pristine, clear crystals. But that still doesn't explain the color. This is where the true secret of the blue salt lies. And I'll tell you, it's not what you might expect. It's a story of physics, not chemistry. The key to that blue hue is a phenomenon called a color center. Now, a color center isn't a substance or some kind of impurity. Nope. Instead, it's a tiny defect, a slight flaw in the crystal's otherwise perfect atomic grid. And that little flaw fundamentally changes how light passes right through it. Normally, a mineral's color comes from trace elements, like copper or iron. But blue halite is different. Its color actually comes from long-term, low-level exposure to the natural background radiation from the rocks all around it. This radiation knocked some atoms out of place, creating those structural imperfections, the color centers, that absorb certain wavelengths of light and reflects back that stunning blue. And this really gets to the heart of it. That breathtaking color isn't because of some foreign element that got mixed in. It's the result of the salt's own perfect structure being slightly beautifully disrupted. It's all a trick of light and geometry. This brings us to a fascinating paradox. For all its ancient origins and its perfect crystalline form, this mineral is surprisingly fragile. The contrast here is just fascinating. On one hand, you have this perfect cubic symmetry, but on the other, on the Mohs scale of mineral hardness, it only scores a 2 to a 2.5. Just for context, a fingernail is about a 2.5, so this salt is incredibly soft and easy to scratch. And of course, being salt, it dissolves in a heartbeat in water, which is a great testament to its origins in those ancient seas. So beyond its beauty, why does this rare salt even matter? Well, because it's not just a mineral. It's a time capsule. It's a message sent to us from a much, much older Earth. You can really think of each one of these crystals as a living archive. Trapped right inside its structure is information about the chemistry of ancient oceans and the climate of our planet millions and millions of years ago. Ultimately, this small luminous stone tells this epic story of transformation. From a vast sea to a buried rock, from being crushed by continents to being reformed in darkness, and then finally, re-emerging as something incredibly rare and beautiful. And that really points to a much bigger idea. If a simple crystal of salt can hold the history of an ancient ocean and the force of colliding continents, it makes you wonder, doesn't it? What other stories are locked away all around us, just waiting to be read in stone?